have other branches of stratigraphy such as lithostratigraphy, biostratigraphy, chemostratigraphy, magnetostratigraphy. So when all these stratigraphies are there, what was the need of the sequence stratigraphy? And I say that the basic difference between sequence stratigraphy and the other disciplines of stratigraphy is that the other discipline of stratigraphy, they depend on the data and directly the interpretation of the data. They never go behind the formation of the data. That what is the process, genetic process that is responsible for the data what you are getting. That doesn't give any other discipline of stratigraphy any predictive capability. So a lithostratigraphy do not give you a predictive capability, a chemostratigraphy or a magnetostratigraphy, they are actually a realistic database, and based on that some interpretation. But there is no predictive capability. There is no capability that all these stratigraphies, they can be applicable irrespective of the scale of a basin. Irrespective of scale of a basin. So the basic idea of the sequence stratigraphy is that it is a genetic process driven stratigraphy. This is number one, and number two, it is a scale invariant discipline of the stratigraphy. So these two are the primary control of the sequence stratigraphy. Today we will be basically discussing the fundamental aspects of the sequence stratigraphy, how really the concept of sequence stratigraphy they took birth, and then it went on evolving. So what are the basic concepts of sequence stratigraphy? Now, we have to think, we have to think in very simplistic way. We will start in a very simplistic way, and then we will be basically progressing into a more complicated manner. So let us start with a very simplistic way. That what is a basin? This I have discussed several times in my earlier course. A basin is nothing but a depression in the Earth's crust which can accommodate sediment. That is what is a basin. So if you have a basin, so if I consider this is a basin which can, very simplistically I am thinking, this is a basin which is basically formed in the, so this is crust, within crust, a depression that is formed which is a basin. Now this basin needs to be filled. So what is the total space in the basin? This is the total space in the basin. If this is the water level of the basin, I am saying, we will see the complications after. Just think of the very simplicity. Now this is the water level. So the space, the volume, I am drawing it in the 2 dimension. You think that it is actually in a 3 dimension. So the total volume, that is what we call the accommodation. Accommodation. That is the accommodation that it is. So the accommodation to hold the sediment, that is what is accommodation. Now this accommodation has to be filled by sediment. Now this accommodation has to be filled by sediment. So sediment will be coming to fill this accommodation. Now the question is that this accommodation may vary with time, because there are 3 different reasons the accommodation may vary. On what factor this accommodation of a basin, when I will go to the other concepts also that separately. On what aspects this accommodation of a basin that vary. Now, if this is the fundamental accommodation, the accommodation can vary if this layer, this upper boundary will go up and down, then the accommodation will vary. Or the lower boundary, it goes up and down, then also the accommodation will vary. Now, if I consider there is a global ocean, and I am only considering the basin as a global ocean. I am again repeating, I am doing it in a very simplistic manner. Now it is a global ocean. Now in the global ocean, if you consider that this is actually the accommodation, then how the accommodation in a very simplistic way, I can vary the accommodation of a global ocean. I can vary it by upward with movement up and down, what we actually refer to as Eustace. So the sea level, the mean sea level that goes up and down. Mean sea level goes up and down. Now, why mean sea level will go up and down? That is again a question. Mean sea level can go up and down for different reasons. There are 5 different reasons for which the mean sea level can go up and down, which are we call the different orders of cycle. We call it first order cycle, second order, third order, fourth, and fifth order. What I am discussing now, I am talking about the movement of the upper boundary of the basin, which I am referring to as the eustasis. Now, why this up and down of the upper layer that will happen? That will happen because of it can happen because of 5 different reasons. Now, which are basically referred to as 5 different orders. Now, what is this 5 different orders? The first order for eustatic variation, that is the supercontinent, amalgamation, and fragmentation. Okay, supercontinent. So if you see the history of the Earth, there time and again, right from the late Archean, before late Archean, we have not that sanguine knowledge that what was the supercontinent or anything, because the continent development that was actually happened during the late Archean, the large scale continent evolution. So if we see even from the late Archean, early Proterozoic, you get the wood, then Columbia, then Rodinia, then Gondwana, and then finally Pangea. Okay, so starting from the late Archean to early Proterozoic. So you get this wood, Columbia, Rodinia, Gondwana, Pangea. So these are the different supercontinent architecture. And repeatedly these supercontinents, they broke in between, and then assembled to form the new supercontinent. So what is the cycles of this supercontinent? The cycles of the supercontinent is hundreds of million years. Hundreds of million year scale, the supercontinents formed and they broke down. So what will happen when the supercontinent form and the breakdown? When the supercontinent will form, the continental areas they will increase, and because of the increase of the continental area, there will be a relative fall in the sea level. And when there will be the supercontinent breakup, then the new mid-oceanic ridges will form, the new spreading centers will come up, and that will cause the increase in the volume of the decrease in the volume of the ocean and the flooding of the ocean water onto the continent. So this is actually the supercontinent amalgamation fragmentation in hundreds of million year scale. Now coming on to the second order. Second order, this actually operates tends to hundreds of million year scale. Second order. And this is related to the variation in plate velocity. Variation is the change in the rate of spreading, the spreading rate of the spreading centers of the Earth. They didn't remain uniform through the history of the Earth. That the spreading rate, they were changed several times with the fast spreading, the slow spreading, fast spreading, and because of that, there is a order of cyclicity that basically operates in the second order, and this some people also relate these things also with the major orogenic cycle, such as Hercynian orogeny, the Alps orogeny, the Himalayan orogeny. So all these orogenies and the spreading rate that basically relate to the second order, that is 10 to 100. Third order, that is related to the glaciation. glaciation and deglaciation. It operates in 1 to 10 million year scale. 1 to 10 million year scale. And we all know the history of last glacial maxima and the fall in the sea level. About 200-meter fall of the sea level because of the last glacial maxima. So the glaciation and the deglaciation, that basically causes another control on the eustatic rise and the fall of any basin. Okay? Now I will come to that. Now fourth and fifth, these two orders, they are related to Milankovitch cycle. Now, you have idea about Milankovitch cycle? Hello?
Yes, sir.
Yeah. So I am not repeating that. I am not going to the eccentricity, not going to the precision, not going to the obliquity. I am not going to that because you people are already told about Milankovitch cycle. Now, these Milankovitch cycles, they basically is responsible for the fourth and the fifth order. Those are the other orders of the sea level change. So now, question is that if you go to the first order and second order, now this first and second order, this will be intercontinental in scale because if you see the tens to hundreds of million year scale, those kind of changes in the eustatic level, that will be intercontinental in scale. It will not be basinal scale. So first and second order, this will be more intercontinental scale. We start getting the basinal scale changes, basin scale from the third order, which is the glacier, and further fourth and fifth order, which may go to 0.1 to 1 or 0.01 to 0.1. So this is 0.1 to 1 million year, 0.01 to 1 million year. That is the fifth order. So these orders that you get more on the basinal scale. Okay. So this is one that the why eustatic sea level that goes up and down. That it is what is more important for us that any change in the eustatic sea level, it goes up and down. It basically causes a change in accommodation in the basin. That is the basic thing that I was trying to tell. Now, forget about it. You now come and do this. What is this? What is this that is going up and down? This is actually tectonics. So the basin floor going up or down. So there is a basin floor uplift or a basin floor subsidence. This is nothing but what is tectonics. So the tectonics can also play a role to change the accommodation of the basin. So it is not only the eustacy that causes the change in the accommodation of the basin, but the tectonics can also play. And I said in the last class, there is always a debate whether the sea level is the main controller or the tectonics is the main controller of the sequence development. Now you see that why there is a debate between the two. That the eustacy can change the accommodation, tectonics can also change the accommodation. Both together can also change the accommodation. Both together can also change the accommodation. So it is not that always it may be basin may be tectonically stable, but the eustatically the changes are there. So it is changing accommodation. Basin eustatically stable, but tectonically uplift or subsidence, that is causing the change in accommodation. So tectonically agile, the basin, the entire control of the sedimentation pattern is by tectonics. But when the tectonics is stable, but the eustacy changes, the entire sedimentation pattern is controlled by the sea level. Now it may happen that both sea level, eustacy and the tectonics, they are operating together and both are also. So we will discuss all these complications, that what signal in that case will happen in the sedimentary strata when the sea level is solely controlling the sequence development. What will happen when the tectonics is solely controlling, or what will happen when the sea level and tectonics both combinedly is controlling. And that is a lot of problem in this the sequence stratigraphy that it addresses. Now this is the story of the basin. Now coming on to the sediment. The sediment has to come to fill the basin. Sediment has to come to fill the basin because basin cannot generate any sediment. So what will bring the sediment? The river system will bring the sediment. So the sediment will come into the basin. Now this is totally independent of this eustacy and tectonic. This sediment, whether high amount of sediment will come, low amount of sediment will come, coarse grained sediment will come, pebbly conglomeratic sediment will come, sandy sediment will come, muddy sediment will come. What will happen? What kind of sediment? So what competence and what capacity of the sediment that will come? That will completely depend on some other independent controls, that is climate, lithology, and hinterland tectonics. This is basinal tectonics. So what are the controls here? The controls are climate, lithology, and hinterland tectonics. That means if I have a humid climate, I have a softer lithology, I expect more sediment to be delivered in the basin. I expect that there is a hinterland tectonics, there is an upliftment, so more chance of supplying of the basin rather than a periplane, rather than a long-term periplane, the source area which will not supply much of the sediment. So all these that will, because ultimately what I will get in the rock record, I will get the rock record, the pattern of sedimentation which might have happened in the Jurassic, in the Cretaceous, in the Paleozoic, in the Precambrian. I will only get the rock record. Now, when the rock was deposited, all these things were happening. Sediments were coming. The basin that was either eustatically modified or tectonically modified, the sediments were coming. They were coming with different kind of tectonic setup, climate, lithology. So all these things were happening. So finally, what will happen? That this change in accommodation and change the different sediment delivery pattern, they will create different kind of stacking pattern, different architecture of the sediment body. That will be finally preserved for us in the rock record. And our idea is that to see that rock record and interpret all those what was happening during when the sediment was getting deposited. Sequence stratigraphy will help you to do so. Sequence stratigraphy will help you to do so. What was happening in the basin? What was happening here? So that too, how it is controlling the entire sedimentation pattern, entire sediment architecture, entire sediment stacking pattern, entire sediment development pattern. So that is actually our goal in the sequence stratigraphy. Is it clear what I have told till now? In a very simplistic way, what is actually sequence stratigraphy? Is it clear, or any question you can ask? Hello?
It's clear, sir.
Okay. after we completed this simplistic pattern of sequence stratigraphy, then we go to some realistic aspect. Same accommodation realistically. When I described it in the simplistically, that I will go to more realistically what really you mean by the accommodation. What we really mean by the accommodation. Now, in a realistic situation, this is the center of Earth. This is the ocean basin, and this is the basin flow. This is the sea flow. I can have a thinner of sediment of Earth on the sea floor, and this is the sea level. Sea level. So, what is the difference between water depth and accommodation? Water depth is actually from the sea level to the top of the sedimentary column. That is what we call the water depth. Is accommodation same as the water depth? No. No. Water depth and accommodation is not same. Water depth is actually from the sea level to the top of sediment, whereas the accommodation is from the sea level up to the sea floor. Because the accommodation will be controlled by the up and down of the sea floor. And that's why the accommodation is defined from the sea level to the sea floor, not the top of the thin sediment here that is present on the sea floor. So there is a difference between the water depth and accommodation, and this accommodation can vary by its movement or its movement, which is called eustacy, which is called tectonics. So this is the further definition of accommodation. Further definition of accommodation. Okay? How we define water depth and accommodation. Now I will come to more realistic case. More realistic case. How we define the accommodation. Please draw it, and once you draw it, then let me know. Is the drawing visible? Clearly visible?
Yes, sir.
Okay.
Sir, in the first figure, what is written after divergent?
Divergent basin, oblique, open global ocean. Open global ocean. Please let me know when it is done.
Sir,
Yeah.
what is the difference between relative sea level and water depth?
The relative sea level I have not talked about. Relative sea level अभी तक मैं बता ही नहीं हूँ वो आऊँगा मैं. What I was talking about the accommodation. I actually don't jump the gun. There are each term in sequence stratigraphy has a meaning. हाँ, relative sea level का बात अभी मैं किया नहीं, अभी मैं करूँगा, I will do. What I have just talked with you the difference between water depth and accommodation.
Okay, sir. So because the definition sounded same to me of both relative sea level and water depth.
Hello.
So I have read somewhere the definition of relative sea level, and it sounded same to me as of water depth.
हाँ हाँ वो सब डिस्कस करेंगे ना.
Okay, sir.
If I indiscriminately use the term, then everything will be hodgepodge. You have to go by the logic. Otherwise, sequence stratigraphy is a full of jargon. There are large number of terms in sequence stratigraphy, and each term has a meaning, and we will use that term when it is required. Now I am discussing with you the accommodation. Okay? हो गया? Have you drawn?
Yes, sir.
Okay.
Yes.
Now we are discussing accommodation. I actually first I discussed in a very simplistic manner a basin and its accommodation. Then in a realistic manner I told that what is the difference between water depth and accommodation. Now I am going to the more realistic in a basin scale, how really the accommodation mean, actually accommodation mean. All these theoretical aspects, how it is applied in real world when you come to a basin. Okay? So I am considering two different kinds of basin. One basin which is an open global basin. That means I have an ocean basin which is connected to the global ocean. And it is connected to the global ocean, so it is affected by all the eustatic change, which is the global eustatic change, and it will be affecting my basin. Or I have a basin which is an interior basin, which may not be always controlled by the eustatic change. So, interior basin. What will be the control when I am in an interior? Suppose the intracratonic basin, a epicratonic basin, a lake, suppose a Black Sea, a Caspian Sea. All these, they are not connected to the global ocean directly. But they are also, because sequence stratigraphy is scale invariant, it can be applicable to all the situations, irrespective of tectonics, irrespective of whether it is connected to the global ocean, not connected to the global ocean. So everywhere sequence stratigraphy is used. But how then I will be defining the accommodation? So in case of the ocean basin, suppose it is the divergent margin. Divergent. We are basically, when we talk about the divergent margin, we are actually talking about the passive margin. So if you see the tectonics, the basin tectonics, and that is also very, very important, because when we talk about accommodation, the tectonic setup of a basin is immensely important, because the different basins, they create the different kind of accommodation at different places, and accordingly the entire sedimentation dynamics, entire sedimentation architecture, that will be totally different. So I cannot apply the unified model everywhere. Suppose when we think about the different basins, what are the basins? Suppose I have a divergent basin, I can have a rift basin, which may be gravel, half gravel. Okay, then I can have a poolland basin. The most important, these are the basin types. I can have a divergent basin which includes the passive margin basin, or I can have a rift basin with gravel and half gravel, and I can have a poolland basin. All these basins, they will behave similarly in their subsidence pattern? No. If you see the divergent, rift, gravel, half gravel, every basin, there will be an increase in subsidence away from the basin margin. In case of divergent, rift, graben, half graben. In all these basins, there is an increase in subsidence away from the basin margin. So, more you go away from the basin margin, you get more subsidence and more depth of the basin. Whereas in a foreland, if you go towards the basin margin, you get more subsidence, because in a foreland there is a thrust emplacement and the foreland goes like this. So the maximum subsidence near to the thrust. Whereas a passive margin, a reef basin, a graben, half graben, all these, they are basically the subsidence increases away from the basin margin. So that is the first knowledge that you require whenever you go for any sequence stratigraphic application, because sequence stratigraphic application, that how the whole architecture of the sediment that is changing from proximal to distal, that is the deep oriented pattern, or along the stripe of the basin. So both stripe-wise variation in the sedimentation pattern and the deep-wise variation of the sedimentation pattern, both are concerned in our sequence stratigraphic application. And for that, I require that what is the subsidence pattern? Maximum subsidence near to the coastline or maximum subsidence away from the coastline? That is one of the major control for it. Anyway, I am not going into that. I am now coming into this. So a divergent basin, and it is an open ocean basin. What is happening here? You have a sea level here, and then this is the coastline. This is the coastline. So what is the accommodation? When you talk about accommodation, this portion up to the sea level, the accommodation, this is what we call the underfield accommodation. And up to this, the accommodation, this is we call the overfield accommodation. So the accommodation now I am changing in the underfield and the overfield. So what is overfield accommodation? The overfield accommodation is that which is the accommodation which it is still, because of the gradient of the coastline, you got the accommodation that is available beyond the sea level. That is what is called the overfield. Am I clear? Because of the gradient, this accommodation. Now think of the accommodation. I am giving a real life. Suppose think of our India. What is the present accommodation? In Indian context, if we see where is our mean sea level, that is the Bay of Bengal or the Indian Ocean. That is where our mean sea level. So is that all sedimentation at present in Indian context all are happening in the Bay of Bengal and the Indian Ocean, because there is only the accommodation, no sedimentation happening in the Indo-Gangetic alluvium? It is happening or not happening?
Yes, sir.
Happening.
Exactly, it is happening. Now, what is that accommodation? It is the overfield accommodation. When I define accommodation, I talk about the eustacy, I talk about the tectonics. Then, if that is the only accommodation, what you will tell about the Indo-Gangetic alluvium and the entire fluvial succession that is being developing here? It is because you have a Himalaya and there is a gradient of the Indian Craton which is going finally to the sea level. So when you cut this total accommodation profile, if it would have been a horizontal line, there would not have been any sedimentation. If the whole thing would have been from Himalaya, there is no Himalaya, and the Indian Craton is a horizontal. So will there be any sedimentation on the Indian Craton at that time? In that case, there will not be any sedimentation, because whatever sediment will accumulate, that will be eroded. Because ultimately, all the erosion that will go up to the mean base level. We will come into the discussion of the base level, sea level, and everything afterwards. But now you just think about that what is called underfield and what is called the overfield. So why we call it underfield? Why we call it underfield? Because in the ocean, now just think about the Indian Ocean, Bay of Bengal. It has the ocean field? No. Ocean is not field. It is accommodating sediment, but it is not yet field. Ocean is not field, it is still ocean. So it is underfield. It is not field now. But if you come to the overlying part in the endoganglionic, it is a subaerial part. It is a subaerial part. So it is a overfilled part. It is not subaqueous part. It is mostly subaerial part, and you are getting the subaerial part of the accommodation, that is the overfilled accommodation. Am I clear what I am saying?
Yes, sir.
Yes, sir.
This is a concept. It should be very clear in your mind. It should be very.
So
Now,
please repeat the underfill accommodation.
underfill. Underfill means the accommodation which is not. It is not fully filled. Underfill. It is not yet filled. And it is the accommodation which is accommodating the sediment. Whereas when you are getting it in the fluvial, it is a subaerial. The endoganglionic alluvium. So that is basically the overfill in the entire foldland system. You get a overfill system. Now, if it is a intracatonic or it is an interior basin. Now, interior basin, you really do not have that control of the sea level. Then in an interior basin, it is the outflow reach that basically is controlling the entire saga. Now, if this is the outflow reach which is above the lake level, the outflow reach which is above the lake level, or the outflow reach which is at the lake level, or outflow reach which is below the lake level. Three different cases of the interior basin. Three different cases of the. In one case, outflow reach that is above the lake level. This is in the lake level, and this is below the lake level. Now you see, when you have a outflow reach above the base level, the underfill part that becomes high. But here, this underfill part, you can have a lake or you can have an interior sea. Suppose Black Sea. That is this kind of a interior basin or a Caspian Sea. Now, what will happen? That in that case, this sea, it may be subaqueous, the deposit may be subaqueous, or it may be subaerial. If it is subaerial, in this accommodation, if this is subaerial, it will be represented by the fluvial or aeolian with no control of the sea level. Or if it is subaqueous, you can have the lake or the interior sea that may be controlling it. So in case of the interior basin where outflow reach is higher, there the interior accommodation, it may not be the underfill. When I call it underfill, it not necessarily. I am not necessarily meaning that it is a pure ocean basin. No. Am I clear what I am saying?
So can you please repeat?
What I am saying, I am now working in an interior basin where sea level has no control, but outflow reach is controlling its accommodation. Now, here I can have a lake or sea. There is no guarantee that always there will be subaqueous deposition. You can have a subaerial deposition also. If it is subaerial, then you can have the aeolian or fluvial. Or if it is subaqueous, you can have a lake, you can have an interior sea. If it is subaerial, then there will be no control of any kind of water level, sea level. But in case of you are getting a lake or a sea, then that may control the sedimentation pattern. Okay?
Yes, sir.
Now coming on to the third. Third, here the outflow reach is at the lake level. You can see the underfill and the overfill. These two portions, in the two cases, they are differing. They are not same. In case the outflow reach is at the lake level, you have a almost similar underfill and overfill system. Whereas in case of the outflow reach is high, in that case your underfill that is much high than the overfill. And in case your outflow ridge is below the lake level, you have the entire overfill. Entirely it is overfill. You really do not get much of. So the underfill portion, it depends upon the outflow ridge and the lake level. What is the relation between the two? What in this figure I wanted to convey is that there is a difference between the open ocean and a interior basin. A open ocean which is controlled by mostly by Eustace, that is totally different from the interior basin which is controlled by the outflow ridge. And the outflow ridge lake level relationship, that will control that how much will be the underfill and how much will be the overfill portion of the basin. This is the basic idea that I was trying to tell. Is it okay?
Yes, sir.
Okay.
Yes, and so can you give the real example for the second and third case?
What is?
So the real example, like we get in nature. The second.
Yeah. One example I have already given you. The Indo-Gangetic Caribbean and the Bay of Bengal and Indian Ocean, that I have given. I have also given you the example of the Black Sea, the Caspian Sea, which are the interior basins. There are several the basins. Suppose if I talk about the basin, suppose the Chhattisgarh basin. How it is? Has it connected with the open ocean? There is no such relationship that it is connected with the open ocean. So the Epiric basin, the Intertectonic basin, all these the Chad basin of Africa, the Michigan basin of USA, the MacArthur basin of Australia, all these are examples of the interior basins.
Okay.
Okay. Fine. Now, if you see as I have, if I now come back to that diagram, which I had just drawn for the divergent ocean basin. This is underfield. This is overfield. Now this is your, I have told this is your sea level. Right? Now this sea level may go up and down. Go up and down. And accordingly, if it goes up, then the sea level, the higher sea level, it will come here. If it go down, the sea level may come here. Okay. So what will happen in this coastal area? The entire dynamics, entire architecture of the sedimentation pattern that will be controlled by the up and down of the sea. Below this is definitely controlled by the sea level. But if I go away from it, where the sea level cannot encroach, will the sea level be controlling the sedimentation pattern? No. No. So if I consider a general pattern, and this is the sea level. So this is so what will happen that this sea level, this can maximum control up to this, which is the maximum rise of the effect of the sea level. Sea level cannot go beyond that. It is not sea level effect, the maximum continent wise that may go up to 10 to 10 to the power square. So 10 to 100 kilometer upstream of the sea level, I can get the effect of the sea level. Tell me, in the Ganges, this is the river, up to what level we get the effect of sea level in the Ganges? Even if you go to Patna, you see every day the tide is coming and going back. Even in Patna, how much is the distance between the Bay of Bengal and Patna? It is about more than 200 kilometers. So every day the sea, it is entering and going back. So sea level is controlling it. Is it controlling it or not? Hello.
Yes, sir.
Are you understanding what I am trying to say? That there will be no control of sea level beyond a certain limit, and that will be totally controlled by some other factors, which we will be discussing separately. And the sequence stratigraphy as a discipline that is basically proposed for this area. That is basically proposed for this area, where the sea level is sometimes coming because of the rising sea level, sometimes going back because of the falling of the sea level. And the continental and marine, these two systems, they are interacting with one another, and that will help me in understanding from rock record that what are the kinds of higher sea level, what are the kinds of lower sea level, how the sequences are forming, how the sediment succession they are forming with different architecture, different stacking pattern, how the system structure forming, all these histories that will come, because here the continental and marine system, they are interacting with one another, they are leaving their own product, they are eroding one another, or they are reworking one another. All these processes, they are going on, and that's why the sequence stratigraphy as a discipline originally is proposed from the observations in this area. But as sequence stratigraphy demands that it is scale invariant and it is applicable to all the environment, I should expect the sequence stratigraphy should be applicable on this side also. I should be expecting the sequence stratigraphy to be applicable on this side also. So yes, they are applied, but with some rider. It is not applied as sensu stricto and the sequence stratigraphy that is proposed for this area. So all the concepts, the basic concepts of the sequence stratigraphy, that basically came with the observation in this area where the marine and the continental sedimentation, they interact with one another and form the different kind of sequence stratigraphy surfaces, the static pattern and the architecture. We will discuss that if I get the application of the sequence stratigraphy here, what kind of sequence stratigraphy? I will not get the simple the low scan, high scan, solid state system track. We will come to that. All these system tracks and this thing which is applicable here, which is not really applicable. There are some other disciplines of the sequence stratigraphy that we apply, and it is essentially the continental fluvial succession where we apply the sequence stratigraphy with some rider. Similarly, if you go to the marine system, the deep marine, when you go to the same marine, the deep marine fan and the deep marine sedimentation, the effects and the controls, they are also different. So one thing we must understand that this is basically the main zone what the sequence stratigraphy that is being done. Is it clear?
Yes.
Now, for doing sequence stratigraphy, what are the things we need? What are the things? How we do the sequence stratigraphy? What are the things we need? We need some discipline. We need some data. And then we try to understand the control. What are the disciplines? It incorporates the sedimentology. Number one. Number two, stratigraphy. Number three, geophysics. Number four, isotope geochemistry. Number five, basin analysis. All these, then basically, and paleontology. All these the disciplines that is incorporated in sequence. Their use is incorporated in sequence. All these are integrated. So the data what? Number one, outcrop data. Based on outcrop we do the different. Number two, well log data. Number three, seismic data. Number four, age data. These are the data that we basically require. Age data. And from outcrop we basically do the facies association and paleo-environment. This is the backbone of sequence and then we try to control that what is the sea level control, tectonic control, climate, deposition of energy, All these are the controls. What are the controls in the framing of the sediment body? The appearance and disappearance of different sedimentary environments. Appearance and disappearance of different sedimentary environments. Their spatio-temporal variation, how the individuals they are varying in space and they are varying in time. All these they are basically utilized to understand the different concepts. Okay. Now, since Ruchi has already raised the issue of relative sea level, I will come to the concept of relative sea. Now, what is Eustacy? Eustacy is absolute sea level. What is Eustacy? Eustacy is absolute sea level. That means the sea level is absolutely going up and down in connection to a global control. The global control, it can be glaciation, deglaciation, it can be a supercontinental level, it can be a Milankovitch cycle, it can be a shear. All these they can fluctuate the global sea level, what we call the Eustacy, that is called the absolute sea level rise and fall. Okay? But the question is that, as I have discussed, that accommodation not only depends on the eustatic rise and fall, it also depends upon the tectonics of a particular area. So that there is, even if there is a sea level rise, global sea level rise, Eustacy, I may get the effect of sea level fall at a particular place. In my area, I am seeing a sea level fall, signature of sea level fall in the rock record, though globally at that time was sea level rise. Now, how can it happen? How does it happen? How does it happen? And why does it happen? This is actually interpreted by this diagram. We try to do. Suppose the sea level that is moving in a sinusoidal manner. So this is plus, this is minus. This is the sea level. Okay? And in a particular basin, this is the subsidence pattern. I am working in a passive margin basin. Now, as I said earlier, originally the sequence stratigraphy concept that has been proposed from a passive margin setting. Why? Why from a passive margin? Why not from a full land? Why not from a field? Why people relied on the passive margin? Because for any model, you have to have some bounding condition. And that bounding conditions that should be well defined. Now, what is very well defined bounding condition in a passive margin? Number one, in passive margin, the sediment is delivered from only one side of the basin. In the passive margin, sediment is delivered only from one side. So if you see a divergent passive margin, the model what is important that there is a supply and there is the sea level. So sediment is supplied. Is there a sediment supply from the opposite side? No. So it is the supply from a single side of the basin, and that is actually helpful for us to model, because we know if we go from proximal to distal part, there will be a finding of the sediment, there will be a decrease in the volume of the sediment. All these are known. If the whole thing from here also there is a supply, then there will be total mixing and the modeling become difficult. So the supply of the sediment from one side of the piece. And number two, this is number one. And number two, in a passive margin, the subsidence linearly increases from proximal to distal. In a passive margin, the subsidence linearly increases from proximal to distal. Not like a bowland that there is a huge subsidence in the proximal and then the subsidence decreases, then again increases. All these complications are not there. So when you have a subsidence linearly increasing and there is the supply from only one side, it becomes easy to control what is its role and what is its role in framing the entire sediment architecture. And that's why the original model was basically done based on the passive margin setting. Now coming on to this, in a passive margin setting, I have a oscillatory sea level. That is the sea level high, this is sea level low. And this is the subsidence curve. This is the subsidence curve. Now this is actually the amplitude. Okay? And what is this? This is time. Okay, so what is important for us finally? So two different control, there is subsidence and also sea level. So how we then do which one has a higher control, which will be affecting whom, how we do that? It is not the absolute. This is the Eustace curve, and this is the subsidence pattern. What we will be interested is the rate of sea level change. Rate of sea level change. Rather than absolute sea level, what will be interesting? At what rate the sea level is changing? At what rate it is increasing, going high? At what rate it is falling? So rate of sea level change and rate of subsidence. That is more important. Am I clear to you? Am I clear? What is more important to us is rate rather than the absolute. Is it clear?
Yes, sir.
Yes, sir.
Yes. Now, what will be the rate of this curve? That will be the first differential of this curve. First differential of this curve is the rate of this curve. First differential of this curve is the rate of this curve. Okay. So when I get the minimum gradient of this curve, here, where is the maximum gradient of this curve? Here. So where the minimum, if I basically draw the rate curve of this curve, how will be the rate curve? Where the minimum gradient, where it is minimum gradient, there it will be at this point, and the maximum gradient will take a high. Then the minimum gradient here, maximum gradient here, minimum gradient here. So the rate curve is something like this. Am I clear? Or if anybody has any problem in understanding, please make it clear. What is this
Repeat
curve?
the curve.
1 minute. What is this curve? This curve is the first differential of this curve. How we did it? We did it by when it will be the first differential, then the least gradient of this curve that will come to the on the line, whereas the maximum gradient of the curve that will take the peak, because it is the first differential of that curve. Is it clear or not?
Yes.
Clear? So what I am getting here, this is the rate of eustatic change. Now we will also do a rate of this. Now this is a linearly increases, so its rate will be constant. Because it is linearly increases, so the rate curve of this will be constant. This is the rate curve of subsidence. At any point of time, what is happening? These and these two curves, they are interacting with one another. These two curves, rather than these two curves, the rate of rise and rate of subsidence, they are interacting with one another. So when they will superimpose on one another, what will be the pattern of the curve? What is happening? That on this curve is, this is the subsidence curve. So if I superimpose the uniform subsidence on this curve, so what will happen? The rises will be more accentuated and falls will be more reduced. Is it clear?
So how?
Is it clear to everybody? I am getting
So why
response
so?
to only one or two.
No, sir.
No. What I am doing, that I have first made a first differential of eustatic curve. How I did it? First differential, that will only depend on the gradient of the eustatic curve. The lesser the gradient and higher the higher gradient part of the eustacy, that will take the peak in the first differential curve. The lower gradient part of the eustacy, that will take the normal value in the, so that and then I have made a first differential of the subsidence curve, which is basically taking a constant value, because it is a linear increase, no variable increase, so it is taking a constant. Now I am superimposing two rate curves, the rate of eustatic change curve and the rate of subsidence curve. So subsidence, it is actually increasing the volume. Subsidence increasing the volume, and when the rate curve of the eustacy, that the rise part, the increase in volume part, the subsidence will add into it, and it will act against the fall part, because it is a overall. If the subsidence would have been uplift, the whole effect would have been completely different on this curve. Is it understandable what I am saying?
Yes.
If it is instead of subsidence, it would have been uplift. What would have happened? The rise part would have been subdued. The fall part would have been accentuated. Have you understood my statement?
Yes, sir.
Because it is a subsidence and it is superimposing on this. So the rise part, what subsidence will do? it will increase the volume. What the rise will do, it will also increase the volume. So one will help other. What the fall will do, it is decreasing the accommodation. What subsidences do, increasing the accommodation. They will work against each other. So it will be depressed, it will be accentuated. What I am saying, if instead of subsidence, I would have taken the uplift here, then what will have happened? The uplift would have gone against this, but would have helped it. So in case of uplift, it would have been subdued, this would have been accentuated. So the two different conditions. You are understanding what I am saying?
Yes, sir.
So when these two, they are overlapping one another, and then we were getting a relative sea curve of the sea level. This is what we refer as relative sea level curve. RSL. So what is a relative sea level curve? It is a superimposition of the rate curve of the Eustace and the subsidence, and these two rate curve, when they superimpose on one another, and they basically totally modulate the original. So because here both the effects are coming, both the effects are coming. So then the sea level that you experience in a particular area, that is what is called the relative sea level curve. Ruchi, could you understand the relative sea level now?
Yes, sir. Yes, sir.
So that is what is relative sea level. There is what I was earlier discussing, the accommodation and the water depth, that is different. This is exactly the relative sea level, and I will actually stop today here because you people see the sequence stratigraphy is not very easy. Even I do not understand fully. If you people do not read regularly and ask me questions, things will not be understood. I can assure you. Okay, so please read it and ask me question so that we can take it into an advanced level. Take the course in an advanced level. Okay.
So which books can we refer for this?
Book. You can take the book. There are two books I can refer. One is the Sequence Stratigraphy by Octavian Cataneo, Sequence Stratigraphy. And there is another Sequence Stratigraphy book by Emery and Mayers. I am writing. Actually, sequence stratigraphy, discussing in class, reading in book, and practicing in field, there is a hell and heaven difference. I can discuss many things in board, but when you go to field or when you will be working with real life data, it is a hell of a job. Hell of a job. It is not very easy, but still we have to read Octavian Cataneo, Sequence Stratigraphy. Another is Emery and Mayers. You can refer to these two books. Okay.
Yes, sir.
Thank you.
Thank you, sir.
Okay, but ये तुम लोग की लास्ट सेमेस्टर रिजल्ट तो आई नहीं ना?
No, sir.
So already I have talked. देखो कुछ हो सकता है I have talked in the exam section. So आज भी बात करूंगा एक बार. देखते हैं क्या कर रहा है. Actually हुआ क्या that university has outsourced is to some organization for doing all sorts of, because there is a see suppose this semester I am giving 30 number, they will make it 50 number, from earlier semester 50 number, who will do all this exercise? Exam section mein to they don't have that workforce, so they have now outsourced and some outside agency they are doing it. I do not know that what they are doing, but whenever I call the exam section, they say company people will come from that company who will discuss with you. This is how the whole thing is going.
तो बाकी कोर्सेज के फर्स्ट सेम रिजल्ट्स आ गए हैं सर, as I know.
बाकी कोर्सेज का आ गया?
Yes sir.
Yes, sir. सिर्फ हमारा बाकी है.
अच्छा ठीक है, मैं एक मिनट तो रुको, अभी तुम लोग के सामने मैं एक बार कॉल करता हूँ, देखते हैं क्या बोलते हैं. ऑनलाइन